Alex from Silicone Expo, and welcome to the Silicone Sessions. Today, I'm absolutely delighted to be joined by Chris Lake, Clinical Prosthetist at Martin Bionics. Chris, how you doing?
I'm doing fine. How are you, Alex?
Yeah, very good, very good. Thank you very much for getting up so early to do this for us.
No problem.
Great. Chris, I'm going to jump right in. Tell us firstly about yourself and your journey to becoming a clinical prosthetist.
Sure. I'm a prosthetist, and that's an engineer who makes artificial limbs. So I work with patients who have limb loss. I've been doing that for about 26 years now. I'll see all levels of amputation, but I do specialize in upper limb prosthetics. So I primarily see patients who need artificial arms. To become a prosthetist, I had to undergo specialized education and do some postgraduate training as well. And then some of that postgraduate training was actually in silicone applications for prosthetics. So it's pretty relevant for today's talk.
Sure. Okay, so what type of engineering is prosthetics?
Okay. Well, prosthetics is pretty unique in the engineering field. It falls into a subcategory called human factors engineering. And what that is that's a type of engineering that focuses on creating machines, tools, and other systems. And while doing that, we consider the capabilities and limitations of the actual person or the human being. The goal then is to develop products and or technology that is safe, comfortable, and effective for human use. So prosthetics fits right within that definition. We're unique in that our field requires knowledge from various levels of engineering. I'll use principles of mechanical, electrical, chemical, and material science engineering every day on my job.
Brilliant. So, yeah, fantastic. So can you give us an idea of your sort of day-to-day role and how that sort of goes back?
Well, day to day, I'll see patients in varying states of prosthetic management. Some patients may be new. They just had their amputation a couple weeks or a month ago. And in that case, I'll be educating them on what to expect, what they need to kind of be aware of, how their residual limb or what's left after the amputation is going to progress and mature. Other patients may be in the clinic for just general fitting or maintenance to their prosthesis, while some may be in for a specialized prosthetic application. For example, I work with children, and I might have a child that is looking to play a particular sport. And in order to do that, I might need to modify their prosthesis or design a new prosthesis that allows that person to, effectively and safely participate in that sport.
Fantastic. Okay, fantastic. So onto the subject of silicone. You mentioned to me that you've been working with silicones from different types of silicones for over 20 years, or around 20 years. But only now you're only seeing the trend of silicone being adopted for applications in your field. Can you tell me why that is and why you are a trendsetter?
Yeah. The prosthetic field in the United States has just been slow to embrace what I'd consider the more progressive nature of custom silicone. Our field, as a whole, one form or the other, has used silicone for 40 years or so. I mean, it was first documented in our clinical and scientific literature in the early 80s for what I would consider widespread use. But we haven't really worked with it to its fullest capabilities. And part of that is when you're working with custom silicone fabrication. And what I mean by that is silicone that you're utilizing in the clinic. It's not something that we buy like an off-the-shelf device or an off-the-shelf type of liner that is made somewhere else, but actually using it in the clinic and customizing it for a particular patient. That has a pretty steep learning curve, and learning really just how to deal with that and get reliable and predictable results. So the moral of the story is that learning curve is measured in years, in contrast to days, weeks, or even months. So it sets a pretty significant barrier to entry to most prosthetists and technicians. But when you get to the field of upper limb prosthetics, I deal with a unique population that has endured significant trauma, and that's how their amputations resulted. In fact, in upper limb, to trauma is close to 90% the cause of why they have an amputation. And so this creates a need for a pretty demanding and accommodative prosthesis. And so I realized early in my career that if I wanted to do better for my patients, I would need to learn how to apply silicone techniques in a meaningful way. And that's how I was going to accomplish that goal. And so I believe a lot of the major strides in silicone application for upper limb prosthetics have led to it being more welcome in lower limb prosthetics. And so it's just not me, but it's a group of probably 30 or so upper limb specialists in the United States that over the last 20 years or so have adopted, utilized, and published on this particular technique. So now it's really a matter of time and awareness for our field to begin to really adopt this across the board.
Fantastic. Okay. So why is silicone material so important to your work specifically?
Well, specifically, it helps me kind of address what I consider to be my patients' unmet needs. And most importantly, that's the provision of a well-fitting and comfortable, prosthetic socket interface. And so the socket interface is that connection between the patient's residual limb, or what's left after the amputation, and all the other prosthetic componentry. So in the case of an arm below the elbow, it's what connects that residual limb to wrist rotators, electronics, terminal devices that are like your hands that you use. And so it's that socket interface that transfers all the force, torque, muscular intention, and excursion of that remaining anatomy to help produce, volitional function of that prosthesis. So it's really the most important part. That socket is the foundation of your house. And without a proper foundation, that house is not going to stand very well. And so by using silicone, carefully within the design of a prosthesis, I can better meet my my patient's needs. And I thought it'd be good to show kind of a little bit of how I use silicone and what my patients kind of look like and what that presentation is. So I prepared a couple of slides to show you a little bit better what I do.
Brilliant, brilliant. Really appreciate it. Let's have a look.
Okay. All right. Oops, sorry. My patient presentation can be varied, but it's primarily trauma when you get to the upper limb, and it's some type of event, a traumatic event that happened to the person's hand or upper arm. And so these patients are pretty varied, like in this slide, they go from very young to a lot older. And their limb, because it was subject to trauma, it never really appears to be the same from patient to patient. Whereas when you get to the lower limb, a lot of those amputations are caused from some type of vascular issue, whether they have diabetes or poor circulation. And so those limbs are a little bit more common, and they're a lot more similar across the board. So how you treat those limbs can become familiar and a little bit more routine and expected. Whereas in the upper limb, you can have 5 patients that have the exact same level of amputation, and those 5 patients look entirely different from their amputation. And then with this group, we deal with a very young group of people, all the way, the range really is from about 16 to 40 or 45 in the United States when you have an upper limb amputation. So you're dealing with patients that are highly active. They have a lot of, work-related tasks or customized or specialized activities they're trying to get into. So it makes for a varied and an interesting patient population. Within my field, we talked about, it's been around for 40 years or so, utilizing silicone to some form or the other. But primarily that use of silicone has been dealing with liners that roll on the limb to make an interface, or more custom types of designs. And so in this slide, you see what a typical application of silicone is in my field, with a liner right here that rolls on the residual limb that has some type of locking mechanism that's down in the prosthesis. And that's how a person connects to that prosthesis, how it suspends to the residual limb. And the other common application is more aesthetics. where you make a custom finger that looks like the finger that has been is no longer there, like you see in this top slide. And those are commonly painted by what we call an anaplastic prosthetist, a person that specializes in the aesthetics type of aspects. And those prosthetists are, engineers that have, much more art in their educational background, whereas I have much more mechanical and electrical engineering in my background.
Sure.
So, why do we use the silicone interface, or why it's so important, and why, I'm excited actually, becoming the Silicone Expo is because, there's 4 main conditions that silicone helps us address, and we'll kind of go through those here in a second individually. But it's dealing with a fragile limb that has been traumatized. It's utilizing the versatility that's not found in any other material. It's the ability to enhance suspension by changing the coefficient of friction across that surface of the silicone, and how I can do some kind of extracurricular techniques to insert air bladders and other characteristics that help address volume fluctuation. And so this is a patient over here on the left, and he has a transradial level amputation. That's an amputation below the elbow. So it's right here. You still have your elbow joint, but you're missing your limb down below. And, silicone helped me design a specific guitar playing prosthesis that he could use his slide with. He wasn't able to do that since his amputation, but we're able to design the prosthesis, and this is the provisional prosthesis right here, and this is the definitive. We're able to design a prosthesis that combined, kind of elasticity and flexibility in a way that he could bend his arm unencumbered so that he could play his guitar. When we get down to it and we start looking at these individual characteristics that silicone is so great at, first and foremost is dealing with a particular limb condition. From the lower limb and upper limb, we weren't designed intentionally to bear weight on any other surface but the bottom of our foot. So when someone has an amputation, they are forced to have to bear weight further up on their limb. And so this is an individual that is amputated below the knee. So he has his knee joint that you can see here, and this is the end of his limb. And what you see is this very end that looks pretty irritated. And there's a kind of a mark right here, and that's a demarcation of an off-the-shelf kind of pad that he was trying to use to help pad that bony anatomy. It's not very smooth there. You can kind of see the bone kind of sticking out some. So this is an application where we did a custom silicone pad that he was able to wear on the very end of his limb to help protect it. And by doing that and going through actually a couple different pads as he healed, he was able to take this limb that looked like this and have it transition to this over about 8 weeks or so. So that's a much better result. So silicone, in essence, helps us replace or supplement kind of those tissue characteristics that are no longer there, or apply tissue characteristics that were only on the bottom of the foot that now we can help bring up further on the limb to help the patient be more comfortable.
Incredible.
The next aspect is versatility. So in my field, we use lots of composites, carbon and fiberglass composites. We use varied flexible plastics, foams and rubbers and things like that. Well, those materials have a pretty set characteristic. And what's set about most of them is they're not very elastic. And they have flexibility, but the flexibility is usually the same across the entire surface of that material. What silicone allows us to do is vary that elasticity and flexibility individually and all across a particular surface. So I can make a silicone liner very specific to that particular patient's needs. Now, what I'm showing here is another kind of application of below the knee. So he has his knee there, and it's a transtibial level amputation. And when you look down into this socket, you see that it's black, but you see these places that are a little bit more milky white. And what those are is those are integrated pads that help pad and distribute pressure across this person's tibia. He had a traumatic amputation and was missing a fair amount of the muscle padding that would have been there. So we're adding back that viscoelastic absorbing kind of characteristic of his tissue. And this is a liner actually made by one of our silicone central fabricators, 14th Element Fabrication. And so you can look around at the different pictures and you can see kind of what those pads look like on the outside. Next is what I was a big surprise to me when I first started using silicone. At first, I didn't like it. Was the coefficient of friction. I didn't like it until I learned how to control it and vary it. Is that we can design a silicone interface that is very sticky or very slick. So what that means is on patients that maybe their skin needs to be padded, but is very susceptible to damage from shear forces, I can make that silicone very slick to where it's not sticky at all. Other patients, like this person shown right here that has a partial hand amputation, I can make the silicone very sticky. And you see, I picked a picture that you can see actually through the prosthesis, so it's not colored. And this is an example of pretty much every aspect except for volume fluctuation. You see two different types of silicone here. This is a very stiff, non-elastic 80 durometer silicone here that's holding the structure of the finger to keep it steady and to keep it secured at the end of the limb. Then you see this other material here that's a little bit more translucent. That's an inner layer of silicone that runs the entire length that is very sticky as well as very elastic. And so what it does is it creates a high coefficient of friction against the skin and holds that finger on so that he can use it in a meaningful way. Then last but not least is utilizing silicone to address volume fluctuation. So in my field, we're dealing with patients with their residual limbs, and the one thing their residual limb is not is static. It is changing throughout the day. It changes from morning to night just based on the pressures they put on it while they walk with a prosthesis or utilize an artificial arm. It changes after lunch if they happen to have, a meal that is fairly salty. And it also changes based on their amputation, their trauma, the circulation and the surgery that resulted after the amputation may leave a limb that does fluctuate, that is not able to handle the volume of the circulation as effectively. So essentially, that limb size changes. So it's like your foot might go from one size to another and have a 2 to 3 size range throughout the entire day. And so it makes it difficult to manage that in a prosthesis. So therefore, we use something that makes it adjustable or dynamic. Now, this particular case right here is someone who's amputated above the elbow. So they're a trans-humeral level amputation. This was a gentleman that was involved in a car accident, and that car accident traumatized his limb so much that his body wanted to create extra bone on the end of his amputation. It was just a physiological response to that trauma to the bone. And so you see that formation down here, which is very problematic. But what we wanted to do is we saw this anatomy here that got a little bit bigger as it went down, and this flared out. So we wanted to see if we could stabilize the prosthesis over it. So even though we use bladders primarily for volume fluctuation, in this case, we use bladders to help suspend over this area. Now, the challenge is to put the prosthesis on, the socket had to be one size, the interface had to be one size, but to wear it comfortably and safely during the day, it had to be another size. So when you look up at this area and you see the kind of dimension at the very bottom, and you compare it down here and you see where the arrows are, this is a silicone inlay that's inside of its flexible plastic socket that you see here that's all black. But within this inlay are individual air chambers designed into the silicone that can be aired up to reduce the size of this area once they put on the prosthesis. So it allows it to be a lot safer, a lot more comfortable, and suspend much better off the patient's limb. So, the main kind of battle cry, if you will, of silicone is it just dramatically or exponentially expands, my capabilities as a prosthetist. So of any of the other materials we use, myself as a prosthetist or my technicians that work with me, there's really no other tissue that's as versatile in its application as silicone is. So it's really been, a paradigm shift and a significant benefit for our patients as a whole.
Yeah. Amazing. I suppose it leads into another question. How do you think silicone materials can improve to further sort of offer a better service to your clients?
Right. At this point, I feel there just needs to be a greater awareness of what the silicone characteristics and capabilities are. And it has to happen both on a clinical side, so me, technical side, and my technicians, as well as the manufacturing side. And this is the primary reason why I'm looking so forward to coming to Silicone Expo, is I want to help the various manufacturers that are attending that become more aware of what we need in the field of prosthetics. So what I find is it's just we don't know what we don't know, and there's usually a solution to most problems if you look hard enough and you expand your view to take in lots of different avenues. So I also look forward to kind of learning more what those manufacturers have to offer today, and see how I can apply that to my day-to-day endeavors.
Yeah, I hope so. And I hope every single manufacturer at Silicone Expo is watching this. I suppose that leads on to the next question. Do you have an idea or what the future holds for silicones in your industry and specifically for Martin Bionics?
Well, specifically, for the industry and Martin Bionics, is the vast majority of all the prosthetic clinics are primarily focused on lower limb prosthetics. That's by far the largest majority of patients that are there. And to that end, Martin Bionics is a lower limb prosthetics focused company. And for specifically for Martin Bionics, is the company itself has been very instrumental at developing some transformative technology for lower limb, so far as socket interfaces are concerned. And this technology has really increased the comfort of lower limb amputees, while they're wearing their prosthesis. And same thing can be said with silicone for upper limb prosthetics. And so, much of the challenges and solutions that we've come up with, in utilizing silicone in upper limb prosthetics has direct translation to lower limb prosthetics. So I'm pleased to have the opportunity here to take what has been successful in upper limb prosthetics and empower an entirely new patient population.
Yeah, amazing, Chris. Well, thank you for your time today. I want to make a big shout out to Maria Cameron from 14th Element for introducing us. But
yes,
yeah, thank you for your time today. Really appreciate it. I'm pleased to say you'll be speaking at the conference on the applications track at Silicone Expo in June next year. So thank you very much for your time. Really informative. Loved it.
You're quite welcome. Thank you for the opportunity, and I look forward to the expo next summer. Take care.